Hi everyone, this is Alex. I am an environmental educator at Forfar Field Station, and today we are going to do our coral conservation webinar, and we're just going to wait a few minutes for people to start coming on. Okay, so we're going to start on our webinar. So again, my name is Alex. I'm an environmental educator at Forfar Field Station, and today we are going to do our webinar on coral conservation. So where to start with this is to learn a little bit, at least the structure of corals and what they are. So a coral is not a plant, but is instead an animal. Specifically, it's an invertebrate that falls under the phylum Cnidaria. In this photo, you can see that there are these coral polyps. And there are two little polyps here. One's a full polyp and one's split in half so you can see the interior of it. And then on the bottom, you can see a cluster of polyps all hanging out together. The polyps are on top of calcium carbonate, and they are protected and live on top of this calcium carbonate skeleton that is secreted by the polyps if they are a hard and stony coral. In the case for soft corals, they instead have a protein skeleton and are really flexible, so they can wave around in the ocean current if they want. One of the most important things, though, about corals is that they have this thing called zooxanthellae. And zooxanthellae is living with corals, and it is an algae. So you can see all those little green speckles on those two coral polyps on top. The zooxanthellae helps the corals photosynthesize and kind of like plants, despite the fact that they are animals. They take in CO2 and waste products of the corals and then supply the corals with oxygen and nutrients they need to grow and survive. And it also gives corals their color. So that's why corals have such cool, pretty colors. So now that you know at least a little bit about what corals are, let's go over what exactly is harming our reefs and why corals are so important. So for today, we're going to talk about these 5 topics here. First one being climate change, and then unsustainable fishing practices, careless tourism, pollution, and coral disease. And within the next few slides, I'm going to go into depth about each one. So first is climate change. So just a definition of climate change for you from the dictionary is a change in global or regional climate patterns, in particular a change apparent from the mid to late 20th century onwards, and attributed largely to the increased levels of atmospheric carbon dioxide produced by the use of fossil fuels. So that is the general definition of climate change. The first part of climate change that we're going to talk about is rising temperatures. So in this graph here, you can see the correlation between temperature and also sea level rise, which we will talk about. And you can see it starting from 1890 up to 2010. From 2010 plus the 10 years where we are at now in 2020, it has only grown from there. So what is happening? As greenhouse gases are getting trapped in our atmosphere, the oceans are absorbing more heat, resulting in an increase in surface temperatures and rising sea level. It's said that the oceans are heating up 40 times faster than estimated 5 years ago, and also absorb 93% of the heat trapped by greenhouse gases. Temperatures on average have risen 1.62 degrees Fahrenheit since the 1890s, which is quite a lot considering that's just the average. But what does this have to do with corals? In concern of corals, rising temperatures can lead to the bleaching of corals, which we'll talk about in our next slide. But a general kind of explanation of it is bleaching corals is when the corals turn white, and if they're bleached for too long, the polyps on the corals can die. Next, we have sea level rise, which we talked just a little bit about with rising temperatures, but sea level rise is happening because those rising temperatures are going on, and with rising temperatures, the ice is melting from like the Antarctic and the Arctic, and also thermal expansion is happening. So as the world is getting a little bit hotter, that water is expanding and kind of contributing to sea level rise. It is said that sea level has risen an average on 8 inches in the last century, while the acceleration rate of sea level rise has doubled in the last century. And it is estimated that by 2100, it will raise between 18 inches to 6.6 feet, which is quite a lot. And in this photo here, you can see how that sea level rise is going to happen throughout time on this particular beach. Again, it's a little bit different on each beach. But again, what does this have to do with corals? So with sea level rise, wetlands and coral reefs are quote unquote drowning, so to say, but they might not be drowning in the same way that you think about drowning. Normally, wetlands are able to grow vertically quick enough to keep up with sea level rise. But recently with sea level rise, the sea level is rising too fast, so the wetlands and any of the plants in there can't keep up. The wetlands kind of work together with corals, and so that contributes to it. Corals, on the other hand, coral reefs and seagrass meadows are in danger of quote-unquote drowning since they can only photosynthesize in relatively shallow water, so they need light. So as that sea level is getting higher, at kind of a too quick of a chance for them to catch up, they aren't getting enough sunlight to photosynthesize. And then next we have ocean acidification. So the ocean has absorbed about 30% of carbon dioxide humans have sent into the atmosphere since the start of the Industrial Revolution. This is about 30% of about 150 billion tons, which is about 2 billion tons per year, which is a lot. So with the ocean being able to do this, it has been able to kind of slow down global warming, but it has been happened at a cost of other animals. So this relatively current trend in ocean acidification is about 30 times greater than natural variation. Natural variation is just the fact that we have things in the past like ice ages and periods of time where the globe has been warmer. So yes, it is true that the ocean, that our world does kind of vary in average temperatures, but the issue of what's happening right now is that we are accelerating that variation at a rate where Earth can't keep up. So with acidity, once we put more acidity into the waters, the ocean is more acidic. And this can be damaging on many ocean species that use calcium carbonate to form their skeletons and shells. In this photo here, you see a crab. So crabs have felt the effects of ocean acidification. In one study by NOAA, it was found that the Pacific's oceans, increasingly acidic water is dissolving the shells of newly hatched Douglas crabs. They have found that the baby crabs need to divert their energy in growing to repairing their exoskeletons. And then with having to divert all that energy, they will on average be smaller. And then also not all of those baby crabs will make it to adulthood, thereby decreasing not only the population, but also the size of the crab. And then as a whole, we look at coral reefs and other ecosystems. It's affecting them because they rely on the formation of calcium carbonate to build their reef structure, which then in turn provides homes for other organisms. So it's kind of taking a toll on whole reef ecosystems as a whole. Now we go in a little bit more about coral bleaching. So I talked a little bit about coral bleaching when talking about rising temperatures, but bleaching can also be caused by runoff and pollution, overexposure to sunlight, and extreme low tides. In the infographic you see here, you can see the different stages of coral leading to bleaching. So you start out with that healthy coral, and then what happens is the coral gets stressed, and it starts to turn white and lose its color. And the reason it has that color is because of zooxanthellae, which means that the zooxanthellae is actually leaving the coral. Without the zooxanthellae, the coral isn't able to get the nutrients that it needs. And with that, if the coral goes without nutrients for a long period of time, then they run the risk of dying and essentially starving to death. There was a bleaching event that happened in the 1980s, and it was estimated that about 8% of coral reefs were affected by the bleaching. But then in 2016, 31% of coral reefs around the world have been affected. And since 2016, it's only gone up from there. Our next topic is destructive fishing practices. So there are a bunch of different destructive fishing practices that do happen. The first one is trawling. So trawling is essentially just the practice of bringing a big giant net down to the bottom of the ocean and dragging it across the floor so that they can catch as many things as they can. At the beginning of trawling, the corals usually would get caught on corals or on boulders, and then the nets would tear. So fishermen didn't use it all that often. But there have been advancements in trawling where they put rubber tires on the bottom, or they put rollers on the bottom so that they can go over the reefs. But with that, it just ends up turning over boulders or taking down corals and essentially being really destructive to anything that crosses its path. And then our next practice, or kind of overarching thing, is overfishing. So overfishing is when fish are fished at such a high rate where the species cannot repopulate fast enough. Thereby, it decreases the overall fish population. For corals, that means that there are less fish to live on the reef, and that relationship is really vital. If you think about fish like parrotfish, who help to clean the corals, and they're being overfished, then there's no one to help clean the surrounding area of corals. And then we have bycatch. So bycatch is one that kind of is not a destructive fishing practice, so to say, but it's a result of fishing. Bycatch is anything that is caught on purpose, or not on purpose, is caught accidentally in the nets of fishermen. And this can cause harm to animals, it can cause them to stress out, and it can even cause them death in the long run of it. This again decreases the population of not only fish, but other animals like turtles and shark populations who are already struggling to keep their populations up. Next, we have dynamite fishing. So dynamite fishing, as you can imagine, is the process of setting off dynamite or other explosives underwater to kill fish for easy collection. So when that big bomb goes off underwater, all the fish die and they float up to the surface. So it makes it really easy for the fishermen to go around and catch all those fish. This is also destructive to corals because it blows up the corals and it leaves them in rubble, and all the animals in that area not just fish will die, but other animals in that area will die. And then it's really hard for those corals and those reef systems to grow back up because it's a slow process, and second of all, it's all rubble and mostly sand at the end, and it's hard for animals and also those corals to attach onto anything. And then last, we have cyanide fishing. So cyanide fishing is a process of crushing up sodium tablets into a squeeze bottle and squirt the toxic liquid into the fish's face. The cyanide will stun the fish, but it won't kill it. So it makes it a really easy catch. This was used for aquariums who wanted fish, so they wanted those fish still alive. And it was a really big thing in the Philippines initially in the 1960s and the 1980s. The reason why it's not great for the ocean, in particular corals, is because that cyanide can kill the coral polyps that are down on the reefs while they are stunning the fish. And then we have phase shifts. So phase shifts can be a result of things that we already talked about, like destructive fishing practices or coral bleaching. So these the phase shift is going from a coral-dominated community to an algae-dominated community, which you can see in this top photo here. You see that really pretty coral community going then into a sadder algae-dominated community. And when this occurs, it's really difficult for the corals to grow back because of all the algae that has taken over. And even though it can come back to life if the algae is cleaned off, it's really hard for it to happen. And the reason why this happens is because of sometimes the lack of herbivorous fish or a large storm event that is covering up the corals in sand, and then the fishes getting fished out who would normally clean up that area. Then next we have careless tourism. So tourism is a really big thing for the oceans. It's really great to educate people about the coral reefs and show them the area and see just how wonderful it is. And it also employs millions of people throughout the world through recreational activities like fishing, snorkeling, and diving. But when tourism is careless is when we run into issues. So one of the first forms of careless tourism is boating. So when we talk about boating, we're usually talking about anchors, like in this photo here. If you were to throw your anchor over the side of the boat and not really know what is under there, you run the risk of hitting onto corals. At Forfar, we do all of our coral sites, or all of our snorkeling sites, anchor in places that are sandy, and then you swim over to the coral reefs. Diving is also a form of careless tourism if it is not done correctly. So if you are a scuba diver, hopefully your instructor has told you that buoyancy is really important. And this is because you don't want to kick up the sediment and suffocate the corals. You don't want to knock down any corals with your fins or your arms or any hoses that are dangling off your gear. And that's why it's really important, at least in your very first course and all of your other courses relating to that, to have good buoyancy and to be really respectful of the marine environment that you're entering. Then also snorkeling can be a form of careless tourism. So snorkeling can be careless in the fact, kind of similar to diving. People, if they are swimming vertically instead of horizontally, can accidentally kick corals, kick inverts, or kick up all the sand that is there. These are all direct impacts on the reef, and they can cause physical damage, as I said, within all of these. But there are also indirect impacts that can harm the reef. This relates to development, construction, and operation of tourism infrastructures as a whole, which includes things like resorts, marinas, ports, and airports, if they don't take the action to kind of care for the environment that they are around. And now we go into our pollution part of coral conservation, which is sunscreen chemicals in the ocean. In the infographic here, you can see that sunscreen chemicals can hurt organisms that aren't only corals, but also other organisms as well. Sunscreen, when you apply it onto your body, will most likely not stay on your body if you are swimming. Even if it does stay on, though, it's probably going to come off on the shower when you rub it all off your body and you're cleaning yourself, which, once it goes down that drain, it's most likely going to end up in the ocean anyways through our waterways. With that, it's concluded that about 6,000 to 14,000 tons of sunscreen lotion are released into our coral reefs each year, which is quite a lot of sunscreen. And there are studies that say that certain sunscreen chemicals are bad for the environment. and they have done studies in labs. One study that was done by International Coral Reef Institute said that when they exposed their corals to the chemicals, large amounts of coral mucus, which was composed of zooxanthellae and coral tissue, was released within 18 to 48 hours. And then complete bleaching of hard corals happened within 96 hours, which is quite fast. Now, there are some places that are trying to decrease the amount of bad chemicals that go into our ocean through sunscreen. One of these places is Hawaii. So they recently passed a bill on May 1st in 2018 that will be effective on January 1st, 2021, to ban the use and sale of any sunscreen that is not reef safe within their country. So it'll be really interesting to see how the coral reefs respond to that in the next few years. And going along with sunscreen, not all sunscreen is bad. There are just certain chemicals in certain sunscreens that are bad. One of the really big ones is oxybenzone, which you can see in that top left photo. And then there are some other chemicals as well, including those two. But there also are sunscreens that are good for or aren't as bad for the environment. And some of the ones that are all right to use in the ocean are on the right-hand side. And if you have been to Forfar, then you've probably heard us do our little rant and encouraging our guests to use reef-safe sunscreen, especially on our boat days when we're snorkeling at our reefs. Now going more into your typical kind of pollution talk. First, we're going to talk about land-based sources of pollution and runoff from the land. So as you can see in this graphic, pollution comes from a ton of places on land and often involves sediment runoff, which can be detrimental to corals. These things include things like deforestation, construction, development, and agriculture, which can lead to a lot of sedimentation pollution, which can cover up and smother corals. Also, things like failed septic systems, stormwater runoff, oil and chemical spills, and especially agriculture can introduce toxins, excess nutrients, and pathogens into reef waters. All these things combined can lead to really bad consequences for the reefs, but there are ways to be able to manage the amount of runoff that goes into our oceans. Going more into our plastic pollution, I'm going to start by talking about the Great Pacific Garbage Patch. This patch is a giant, slowly swirling dead zone in the middle of the Pacific Ocean that contains extreme amounts of plastic pollution. It has come to be because of ocean currents and them gathering all the plastic into this one kind of giant area. Most of the garbage, though, doesn't look like the photo on this bottom corner. Usually, it's actually just a lot of seawater filled with hundreds of millions of tiny plastic pieces called microplastics. These tiny plastics can either be made from microbeads or can come from really large pieces of plastics breaking down and turning into smaller pieces of plastic. With that, it's really important to remember that every single piece of plastic that has been made on our Earth is still here today, and most likely has probably degraded down into little microplastics. But why is this bad for the coral, though? This plastic floating around the ocean. It's bad for the coral because it can strangle them and contribute to the chance of corals getting diseases. The UN Environment Program said in a study that of 124,000 individual reef-building corals that the study assessed, 89% of those smothered in plastic were facing the threat of disease, compared with only 4% in corals free from plastic. The plastic debris starves the corals of vital oxygen and light, and also releases a bunch of toxins, enabling bacteria and viruses to be able to enter the coral. So pollution is really not great for our environment. And then our last slide on pollution is harmful algae blooms. So what are harmful algae blooms? They are another form of runoff pollution, and they are also called HABs for short, which I will probably call them in the rest of these slides. They look like this and become this huge blanket of algae that can cover a really large area. The change in properties of the surrounding water makes it so that creatures can't live in those areas. And it can even cause rashes and liver damage to humans. So not only is it bad for our oceans, but it's also bad for us. Because of these algae blooms, and because of the fact that they hang out in the top water column or right below it, it completely blocks out sunlight from anything that's underneath it, including coral reefs. So the coral reefs need low nutrient waters and enough light to be able to photosynthesize, and these algae blooms completely take out that light, and then the corals can't get the nutrients, which then causes them to bleach from the stress from the corals. And then going and talking about disease, we're going to talk about the different kind of diseases that corals can get. So coral disease happens as a response of biological stress, which I might have mentioned earlier. So biological stress is things like bacteria, fungi, viruses, and it also can come from non-biological stressors. So things like sea surface temperatures, ultraviolet radiation, and pollutions. So basically everything that we talked about earlier. But to start, I'm going to talk about the different kind of coral diseases that can be found in the Caribbean and the Atlantic in particular. The first one being black band disease. So black band disease is in that top right corner, and you can see there's that white coral bleached on top, and then there's that black ring, and then there's live coral on the bottom. What happens is it starts at a single point on top and then destroys the tissue and then moves over the colonies and leaving behind just that white skeleton of the coral. The disease is known to kill entire colonies within a matter of a few months, but one kind of okay thing to it is that if the black band is to disappear and go away, the corals unharmed on the bottom can still live and then grow back very slowly. Next, we have white band disease. So you can see it in that top left photo. And white band disease, instead of starting on top like the black band disease did, it starts at the root and then it goes up to the tips. So you can see in that photo, it started from the base and is slowly moving up. And then we have stony coral tissue loss. So I'm actually going to talk about stony coral tissue loss in our next slide, but it was first discovered in Florida in 2014, and it is known to spread really quickly. The characteristic of the disease is that the sick colonies display multiple lesions and die pretty quickly. The species that are most susceptible to it are any sort of corals that are hard corals or stony corals, given the name. So this is like brain coral and maze coral and starlight coral. And then last we have aspergillosis, and this affects sea fans, which are a soft coral. So there is a pathogen that was identified as Aspergillus sedoi and is a common terrestrial soil fungus. And the symptoms of the disease included expanding areas of the sea fan in which the polyp tissues were destroyed and exposed that skeleton underneath of the soft coral, which you can kind of see in that bottom left photo there. Now we're going into NOAA's efforts against coral disease. So I mentioned stony coral tissue loss disease, and that is what is being focused on with NOAA and their efforts. So ironically, we actually just recently turned into a webinar all together as staff with the Perry Institute, and they went really in depth with this subject, and it was really interesting to learn about. So what happened is in lower Florida, an epidemic zone with the highest concentration of the active disease started in 2014 with stony coral disease. It was thought to have been transferred through direct contact and water circulation. As you can see in the bottom graphic here, which I will try to play, you can see that starting from 2014 and each year continued, it only grew rapidly around the areas. Now this graphic is from NOAA, and I think it's really well done to show that expansion. So there is a breakout of disease occurring, but NOAA has been co-leading with the coral rescue team to help save the corals in Florida from completely wiping out. One of the things that they do is they take healthy corals and replace them into an aquarium to prevent them from being diseased and to preserve their genetic diversity of the coral so that they can use them and their genetics for future activities of replanting. The corals that are chosen to be taken out are chosen because of how well they build on coral reefs, their current abundance, how fast they get the disease, and how fast it spreads within them, and things like that. So they're choosing the healthiest corals. The teams that have relocated sick corals to a care unit in North Carolina, where NOAA's National Centers for Coastal Ocean Science team created an antibiotic that can actually be directly applied to the corals. So it's kind of like a cream, you can say, or an epoxy that can be applied directly to the corals to help prevent them from getting any of the diseases. So there are trials happening in Florida in particular to try to get this antibiotic to the corals, but there are still questions on it as a whole, one of those being money if they're able to afford it for all the corals. Now we're talking about Florida and with stony coral tissue loss disease, and in 2019 this disease actually appeared in the Bahamas, and the first one being Grand Bahamas. It is thought that the disease came in through water ballast, so water from other places being discarded in the Bahamas, or through people bringing it through fishing or dive boats that do not disinfect their boat gear or even personal dive gear before coming from another place. This is most likely what happened, but it's not exactly proven yet where exactly or how it came into the Bahamas water. In some other places, the disease is thought to be spread through natural ocean currents, but there's no currents from Florida that come into the Bahamas, which is why it's probably not ocean currents. And in our top photo on the left-hand side, this is actually a coral that was treated with the antibiotic and is tagged so that it can hopefully be monitored and seen if the antibiotic works. So now I talked about all the really, really bad things that can happen to corals, that are happening to corals, and telling you that they're dying all over the place. But there are things that are being done to help, to try to save the corals and to also save the oceans as a whole and keep them alive so that other people and other fish can enjoy them as well. So one of those things is growing coral, artificial reefs, education, and citizen science, and also legal protection. So these are some of the things that I will go into detail in our next few slides. So first, we have our coral propagation site. So the pictures shown here are actually our own coral propagation site that we own at Forfar. And in the bottom photo, closest to us is Kosh, who is our current station director. And then in the back is Vivian, who is our past station director, who are cleaning the corals and making sure they're all nice and healthy. So this coral propagation is at one of our dive sites. And we have been replanting these corals and growing them so that we can hopefully at least help to rebuild the reefs. And we will explain that in our next slide of how we do that. So coral propagation at Forfar. So all these corals are lined up on the little lines and they grow in between 1 to 3 years into nice big corals. And then we take some loppers, as you can see in that top photo, and we cut off the coral and leave about a 3-inch piece still attached to the line. We leave that 3-inch piece and cut them off because they are asexual, and once we replant them into the marine environment, they will continue to grow. We then collect them in a crate, like that bottom photo there, and bring them over to our outplanting sites, which are A-flats or string quartet. And strings quartet is part of the barrier reef and is where we have been outplanting for our last 2 outplants. And then we go over to string quartet and we rebuild them. So you can see in that top photo up there, a diver is planting all those corals, and in that bottom photo, you can see the finished product of a coral being outplanted. So what we do is we go to the area, we dive down, and we find a place where there aren't a lot of corals. There's a nice substrate where there's not a lot of algae or anything that can compete with it. And also an area where there are some little wedges or holes where we can put the little coral piece in and it can be nice and safe in its little home. We then use epoxy, which is a 2-part epoxy that is made on the boat and dries within 45 minutes. It's a marine safe epoxy, so it's all good to be using. We use a little bit of that epoxy, put it into the hole, put the coral into the hole and stick it in, nice and secure. And then those little fragment pieces grow. We have partnered with Perry Institute and Reef Rescue Network to be able to have this site and to properly outplant our corals. Our site was started in 2015, and since then we have outplanted over 150 fragments, which is a lot. Some and not all of them make it for a variety of reasons. It can be stress of travel or competition with other corals in their new environment, but there have been a lot that have actually been able to grow, and they're tagged. If you're ever at Strings, go look for the tagged outplanted coral. They're really fun to see grown about. And then next we have artificial reefs. So artificial reefs are kind of the same idea, and a lot of people have been looking into building them. An artificial reef is anything that started off as a man-made thing, and then corals have started to grow on it. Sometimes it is something that is put down in the ocean on purpose. So you can see in the first 2 photos, the really big one and the one on the top left, that those are ones that were put down there on purpose, and people have planted corals onto them and stuck them on there so that you can build that artificial reef. Or it can be an old shipwreck, a car, or some sort of vehicle like in that top or in that bottom photo on the right-hand side. Even though artificial reefs are not a replacement for the real thing, they do attract many different reef species, and many of them have actually been really successful. There is currently a really large study that's happening on the biodiversity around the reefs and seeing how they do and if they're stable, etc. Next, we have awareness campaigns and education efforts. So I'm educating you right now about corals, but there are also awareness campaigns in other places that do education. First one that we're going to start out with is awareness campaigns. So movies and art pieces are 2 really public forms of media that can help educate about reefs. One really popular movie is called Chasing Coral. That is on Netflix. So if you're at home, go and watch Chasing Coral. You will learn all about corals and how they are being affected in our world today. So go ahead and watch that. But then there's also art pieces. So there's art projects like this really big shark here that's made out of plastic pollution that was found on the beach. This shark is named Greta the Great White Shark, and it is in the Moat Marine Laboratory and Aquarium. And the reason why they do things like art pieces is because scientists have all these numbers and all these things that might not compute in a regular person's mind. And putting it into an art form can help flip that switch to make them understand what is going on or just make them see the big picture of it. So that is awareness campaigns. But then we also have education efforts. So there's things like citizen science projects. Not only do they get everyone involved in helping, they also spread awareness. There's one called Coral Watch, which is pictured here, and it lets snorkelers and divers help collect data on coral bleaching around the world. The Citizen Science Project was created in Australia, but has since been used all over the globe. And we even have a few slates at Forfar. If you're ever there and want to take a look at them, let us know. And then at the Bahamas, we have something called Reef, which is the Bahamas Reef Environment Educational Foundation. They do a ton of teaching in local areas about the importance of reefs and how we can protect them. And it's really important for people in these local areas, local coastal areas in particular, to understand the impact of their actions. They may have, and they have this marine world around them. And then Here at Forfar, we are doing education ourselves, so we definitely believe in the idea that education can make a difference. And then last, we have legal protection. So for legal protection, I'm going to focus on marine protected areas, or MPA, which I will most likely call them on this slide. In the map here, you can see a bunch of different marine protected areas. All those really dark blue spots are where they are. The definition of a marine protected area is areas of the ocean set aside for long-term conservation aims. They are the only mainstream conservation-focused, area-based measure to increase the quality and extent of ocean protection. MPAs and their network offer nature-based solutions to support global efforts towards climate change adaptation and mitigation. This was coded by the IUCN. So, what do these MPAs do for corals, though? There has been a study done, and I will read a little bit about this case study. And they did 993 surveys that were repeated at least twice, and 306 of those were in the Caribbean. What they did is they constructed different multi-level models to compare changes in coral cover over time between MPA and non-MPA areas and their reefs to determine how the number of years of protection in MPAs affected the changes in coral cover. What they found is that MPAs can actually be really effective in preventing coral loss. What they found is that in some places, in particular the Caribbean, after the area became an MPA, the decline still happened for 14 years, which is quite a bit of time. But after 14 years, the decline instead started going up, and the corals began to grow again, and it started to be a more biodiverse place for fish to come in. So, in result, they found that MPAs can actually be really beneficial to protecting our corals, which is pretty awesome. There are a few MPAs around Andros, one being up at Jolter Keys, one being at Pigeon Key, which most people have gone to if you have been to Forfar. And the west side is also a marine protected area, and then there's one other either north or south of us that's about the size of Pigeon Key. But now I talked about all the really amazing things that people are doing within the ocean, but everyone is at home right now. So what can you do to help the corals still? One is not taking or touching when you are in that area. So maybe not at home, but if you are in that area, don't touch any of the corals or any of the fish that is there and disturb them. And also don't take anything that is there, especially corals. And it's illegal in the Bahamas to actually take corals away from the Bahamas and bring them through customs. Be safe boaters and snorkelers. So again, as I said, at Forfar, we anchor all of our boats at sandy patches, and we also enforce the otter rules, where you are always snorkeling in a horizontal position instead of a vertical position. And then at home, you can say no to single-use plastics, so things like water bottles, bags, straws, cups. You can bring reusable bags out to the grocery store. You can use reusable straws, reusable water bottles or coffee mugs, and things like that. Also be aware of your fossil fuel usage and carbon footprint. Now, I'm not saying don't ever fly anywhere or don't use a car again, but just be aware of it. Be aware that sometimes you can just walk to one place or you can take your bike, and just be aware of what is going on and what you are doing. Donate is also a big thing, and we're not just talking about donate in money. Yes, there are places right now that do need donation in money, but also when we get the chance to, again, donate your time. Donate your time not only by going to the places, but to spread awareness to your friends and things like that, and family, which then goes into spreading awareness. I'm spreading awareness right now in this awesome format of being able to give you a webinar, but you can spread awareness by just having a conversation with people that you know, and word of mouth gets around quickly. So that is our webinar for today on coral conservation. If you have any questions, I am just going to pull them up right now and see if there are any. Well, if you have any questions, go ahead and ask. If not, we'll wait a few minutes. So in this photo here, this is actually our coral propagation site. And you can see that there is both fused coral, which is a fused combination of elkhorn and staghorn. And then there's also some elkhorn by itself and staghorn by itself. When we go and clean them, it's really fun because you just scrape off all the algae that's there. We go and clean them every month, and all the little wrasses and fishes will come around and eat all the falling algae and anything else that was growing on the coral sites. So yeah, so I guess if there's no, I'm just checking right now. So if there are no questions, then we will end the video there. Thanks so much for tuning in to our webinar today. If you have any questions, feel free to ask them later. But again, thank you, and we'll see you on our next webinar.